Okay, I want to talk to you about solving some of these problems we've discussed in class with motion. So the first one we're going to look at is our speed problems. And our problem here says calculate the speed of a speed skater that travels 500 meters in 19 seconds. Remember, we have a standard method for solving word problems. So our first step is to identify our knowns. And I see that I have 500 meters and 19 seconds that has been given to me. Now, when I label these knowns, I recognize that meters is distance and seconds is time. I'm going to check my units. Meters and seconds go together, so it's okay for me to use them as they are. If I had been given hours and meters, I would have needed to change either the hours to seconds or the meters to kilometers to make sure that they match. Substitute and solve is our last step here. And so I'm going to take this 500 meters in 19 seconds and put it into the equation velocity equals distance divided by time. Now remember, you have this triangle. For those of you that need the triangle, you take the distance divided by the time and put them into the triangle so that they still divide, and put the velocity in the place that's left over. 500 meters divided by 19 seconds will give you 26.32 meters per second. The meters and seconds don't cancel. That's how I know that I need to include both of them in my unit. And by including the units in my math, it gives me an opportunity to check to make sure that I've done the math correctly. Velocity is measured in meters per second. So the fact that that's what my math problem gave me, that gives me some confidence that my answer is correct. Okay, acceleration problems. We have tests on a new Speedmobile show that it can decelerate from 96.2 meters per second to 39.7 meters per second in 4.352 seconds. What is the vehicle's deceleration? Now I know that this is an acceleration problem because I see, when I identify my knowns, I see two different values for meters per second. Those are two different velocities. So I know I'm going to be needing to use a different equation than the one that we had before. Now, we have these two velocities. We also have been given 4.352 seconds. Now, when I go to label this, I have to make a decision for these two velocities. I have to decide which one came first. So when I read the problem, I see this keyword from and this keyword to. That tells me which one came first. The from is the VI, the initial velocity, and the to is my final velocity. This 39.7 meters per second is my final velocity. Now, this 4.352 seconds is my time, so I'm going to check my units. I want to make sure my time unit matches with my velocity unit. And since I have meters per second and seconds, I know those match. If my velocities had been given to me in kilometers per hour and my time had been given to me in seconds, I would have needed to change my seconds to hours before I did the problem. Now, I'm going to substitute and solve, and the equation we're going to use is our acceleration equation. A equals VF minus VI over T. Now notice that I haven't worried here about subtracting a large number from a small number. I'm going to put it in according to the formula last minus first. So 39.7 minus 96.2 divided by the 4.352 seconds. Now I'm going to do that subtraction first, and then I will divide by the time. And when I do, I'm going to get a negative answer, but that's what I should get because we were looking for deceleration, and deceleration is negative acceleration. So I get negative 12.98 meters per second squared. Now, when we're talking about acceleration, we can always go vertical. And when we go vertical, our acceleration is going to be gravity. These problems look harder than they are, so just follow the steps with me and you'll see, hopefully, that they are easier than they appear. So the question says, a stone dropped from a building strikes the ground in 4.2 seconds. How fast is the stone falling? We only see one piece of given information. We've been given the time. And when we only see one number in a word problem, that makes us very nervous. But remember, there's something else that is given here. This word falling tells me, drawing a picture is always helpful, tells me that when this stone is falling, something made it fall. And that something is gravity. So gravity has been given to us. And gravity is 9.8 meters per second squared. So now we're going to label the other things that we've been told, which is just this 4.2 seconds. And I know that that 4.2 seconds is time. Now, because I've drawn this picture, and I know that it was dropped, this stone was not thrown off of the building, I know that its initial velocity, when I first let go of the rock, is 0. Its initial velocity is 0. So I started with just one piece of information, and now I have 3. I'm going to check my units, and everything's okay because I have seconds here and seconds squared in my gravity. And now I'm going to substitute and solve. Now the equation that we start with for this problem is the same as any acceleration equation. A equals VF minus VI over time. Now the VI is 0, so I'm just going to mark it out because a 0 is not going to affect my equation. And then I don't want A. I was asked to find how fast is this stone falling. So I want the VF. I want to know how fast it was going right here, right before it smacks pavement. So I need to multiply by the time on both sides in order to get the VF by itself. And so now I will be left with a formula that we'll use. VF equals A times T. Now, what is A in this problem? A equals acceleration. And when I'm falling, my acceleration is due to gravity. So I can change this to gravity times time. And the gravity was 9.8 meters per second squared. The time is 4.2 seconds. When I multiply those two together, I'm going to get 41.16 meters per second. Now, for those of you that like triangles, you may use a triangle here, but please remember, this triangle is only true if VI equals 0. If you have a value for VI, you cannot use this 3-variable equation. You would have to use the equation for acceleration that includes VF minus VI. Now, whenever we're talking about vertical acceleration, some of the problems will require you to solve for the weight of the object. So I want to make sure we discuss how to do that. Weight problems are very tricky at first glance, but they're very simple once you know the steps to take. So it says, what is the weight of a 60-kilogram person on Earth? Again, this is another one of those problems that only gives us one piece of information, and that's what makes it intimidating. When I identify my knowns, I only see this 60 kilograms. But I also have a word phrase that's important, and it's right here. It says on Earth. Because gravity is different on every, planet or star that we were looking at, so I have to know where this person is before I can calculate their gravity. Their weight. So now I label my knowns, and I know that this 60 kilograms is the mass, and on Earth I will experience gravity. So when I check my units, I'm going to assign gravity's value for the planet that I've been identified. So I'm going to have 9.8 meters per second squared. That is the rate of acceleration for gravity on Earth. Now I'm going to substitute and solve. Well, we had this equation, F equals ma, from before, and hopefully you'll see the similarities. Weight is a force, mass times acceleration, or gravity, which is a form of acceleration. So weight equals mass times gravity. 60 kilograms times 9.8 will give us 588 newtons. That's our weight for this 60 kilogram person. Now our weight triangle over here, the weight's on top and mass and gravity are on the bottom. Now that leads us to the most complicated kind of problems that we can have, and those are the two-step problems. They are going to require us to do one piece of math work before we can get to the answer that they're asking us for. So let's look at this problem. What force is required to accelerate a 1,500 kilogram car from rest to 40 meters per second in 6.7 seconds? My first step is to identify my knowns, and when I do that, I see that I have 1,500 kilograms, 40 meters per second, and 6.7 seconds. But notice I have the phrase from rest underlined as well, because from rest is a numerical piece of information for us. When I label my knowns, the 1,500 kilograms is mass, the 6.7 seconds is time, and this from rest tells me my initial velocity was 0. Now my final velocity is 40 meters per second. I'm going to check my units. Now I know that I was asked for force. It says what force? So I need mass times acceleration to find force, and I have the mass, but I haven't been given any acceleration. So that clues me in to the fact that I'm going to need to do something here to find the A before I can find my force. Now let's get ready to substitute and solve. The formula for finding force is F equals ma. I have the m, but I need the a. Well, I need to use my acceleration formula first to find it. So I take my final velocity, which is 40, minus my initial, which is 0, divide that difference by the time, which is 6.7. And when I do 40 divided by 6.7, I get 5.97 meters per second squared. Now I have an A value for this vehicle. I can now put this in the place of A, multiply the mass times that acceleration, and I will find that my force for this vehicle to accelerate is 8,955.22 newtons. Now, again, this formula would work in the triangle F equals ma, with the ma on the bottom and the force on top.